So a few more examples on area between curves. Find the area of the region enclosed by, so let's say y equals 2x squared plus 10 and y equals 4x plus 16. So this region enclosed by these two curves, well, this is a straight line and this is a parabola that's open upwards. Okay, so that's the first thing you should tell yourself. What are these shapes? Line, parabola, that's open upwards because the coefficient of x2 is positive. Okay, so I'm gonna have something like this. I don't know what, but something like this. Okay, parabola open upwards and a line. Now, in order to draw it correctly, okay, I don't need to be very, very precise when I draw it, but at least the intersection points are very, very important. Okay, this we need. So let's find the intersection points right away. And that will help us to draw the graph as well. The region, I mean. So intersection points. So of course you solve the system by making this equal to that. So 2x squared plus 10 is equal to 4x plus 16. I send everything to the left. 2x2 minus 4x minus 6 is equal to 0. Divide everything by 2. x2 minus 2x minus 3 equals 0. And then you factor x minus 3, x plus 1 equals 0, which means that either x is -1 or x is 3. You all found this, I guess?
Yeah.
Okay, and now if x is -1, right? If x is -1, then the y will be 12. And then if x is 3, if x is 3, y is 28. That's what you got?
Yeah.
Okay, so these are my two intersection points. Okay, so let's draw. So -1 and let's say 12 somewhere here, and then 3 and 28 somewhere, I don't know, somewhere here. Straight line. And I have a parabola that's open upwards. So I think it looks something like this. Okay, so again, it doesn't need to be very precise, but at least show me that this is a line. Okay, so you could even put the y-intercept here at 16. That's a reference point, right? The y-intercept is 16. Place the two intersection points between the parabola and the line, which are 328 over here and -1 and 12 over here. And also, it's good to notice that the vertex of this parabola is 0, 10. Okay, you don't need, but it's just for you to have some reference points to draw your graph, to draw your region. Any questions until here? Okay, so this now, I'm just gonna label them so that I see clearly. So this is y is 4x plus 16, and this is y equals 2x2 plus 10. And at this point, it's very easy to set up the integral for my area is top function minus bottom function. And x goes from -1 until 3. top function 4x plus 16 minus bottom function, which is 2x2 plus 10. Do not forget the brackets, right? Dx. Okay, let's calculate this. So it's the integral -1 to 3 of -2x squared plus 4x and plus 6 dx. That is -2x3 over 3 plus 2x squared plus 6x, and all this evaluated from -1 to 3. Okay, at this point it's just plugging in 3 inside. So 3 power 3 is 27. 27 over 3 is 9, so that's -18. Plus 9, so that's 18. And then plus 18. This is when I plug in 3, that's what I get. Minus, when I plug in -1, I have negative, so 2/3, plus 2, and minus 6. Okay, that's what I get. So this is out. So it's 18 plus 4. 18 plus 4 is 22. So 22 and 2/3. So 64/3. That's what I get.
Sure, I did it again and I still get minus.
I think maybe the error was that you subtracted the bottom one first. That's what I did at first.
So find again the area of the region enclosed in y equals, no, not y equals, let's change. X equals 1/2 y squared minus 3, and y equals x minus 1. Okay, so what is this? I have, this is a straight line, that's easy, but what's that? This, I don't know what that is. Have you done conic sections in high school? You probably did. This seems like it's a parabola, but it's open sideways. Okay, if you were to isolate the y here, you'll get a plus or minus square root, which is square root, square root. So it gives you sort of a parabola open to the right. Okay, so you have to know this.
Sir?
Yeah.
We didn't cover conic sections in high school.
Okay, it's okay. We can manage without. Okay, so basically, if it was if it was the regular y equals 1/2 x2 minus 3, that's easy. It's a parabola like this. Okay, which with its vertex at 0 minus 3. Since now it's x equals 1/2 y2 minus 3, so the y is the independent variable here. It's the same thing, but open to the right. It's like if your x, it's like if you rotated your Cartesian plane. Okay, let's find the intersection points first. Okay, then we'll draw. So I have to solve the system x equals 1/2 y2 minus 3 and y is equal to x minus 1. Okay, so how do you solve this? There's many ways. Okay, I mean, what I would do is I would replace the y on the first one by x minus 1 and I will solve for x. Okay, that's what I would do. But there's many ways. So x equals to 1/2 times x minus 1 squared minus 3. Is that okay?
Sorry.
Excuse me?
Sorry.
That's your y.
Sir, I have a question.
Yes?
Would we just be able to replace the whole value of x in y equals x minus 1?
Yeah. Like the x here, you replace it by, yeah, same thing. Of course. If you do it that way, then you will find the y first. You'll have an equation with just y, so you'll find y. If I do it this way, I'm going to find the x first and use the x's that I found to evaluate y. It's okay. It's perfect. Both work. Okay. So I'm not a big fan of fractions, so I'm going to get rid of this half by multiplying everything by 2. So 2x, this, if I multiply by 2, stays x minus 1 squared, and this becomes minus 6. So 2x, I'm going to open this up, x2 minus 2x plus 1 minus 6. And so x2 minus 4x minus 5 is equal to 0, and therefore x minus 5 times x plus 1 is 0, which means that either x is negative 1 or x is 5. Okay, so that's a simple quadratic equation. I'm solving the quadratic equation right here. Pretty easy. And now I can find the y by replacing x by negative 1 in any of the two. I'm going to choose, of course, this one because it's much simpler equation. Minus 1 minus 1 is negative 2. And if x is 5, 5 minus 1 is 4. And so these are my intersection points. Negative 1, negative 2, 5, 4. Any questions? Okay, let's try to graph this region now that we have two important points on my region. One, two, three, four. 1, 2, 3, 4, 5. Negative 1, negative 2. So let's place negative 1 and negative 2 is right here. And then 5 and 4 is right here. Y equals x minus 1. It's very simple. It's a straight line like this. And x equals 1/2 y2 minus 3. I told you it was a parabola open to the right with its vertex, right? When y is 0, x is minus 3. So when y is 0, the x is minus 3, so right here. So basically, it's a parabola open to the right. That's what I have on my region. -1, -2, 4, 5. I'm just going to label everything so that I have everything organized here. So y equals x minus 1, and this is, of course, x is 1 half y2 minus 3. Any questions until here? Okay. And now I have a problem because now I need to find the area. And to find the area, I need to do the integral of the top function minus the bottom function. So the top function, no problem. I just need to isolate the y here. Okay? But the bottom function, as you see, it changes. At first, from -3 to -1, it's this branch of this parabola. And starting at -1, until 5, it becomes the line. You understand?
Sorry, could you repeat what you just said?
I'm going to repeat that. Okay? Just running out of colors here. Let me just do it blue. Okay? This, if I am to express everything in terms of x, okay, so I must isolate the y here. Okay, so if I isolate the y here, I will get y is equal to the square root of 2x plus 6. That's what I'm going to get. If you isolate y here, that's what you're going to get. Okay, I could do it on the side here. X equals 1 half y2 minus 3. So send it, so x plus 3 is 1 half y2 times 2, I get 2x plus 6 equals to y2. And so y will be plus or minus square root of 2x plus 6. So I don't know if you can see. Okay, so the top, what does the plus or minus mean? Means the top branch of this parabola is the plus square root, and the bottom branch of the parabola is the minus square root. Are you with me?
Yeah.
Okay, so now if I want to find the area, I'm going to do the integral. So from -3 to -1 will be top function. So I have to separate the region in two parts. The first part is from -3 to -1, where the top function is square root of 2x plus 6 minus the bottom function, which is negative root 2x plus 6 plus, and then the area from -1 to 5. I'm going to do it below here because I'm out of space. From -1 into 5 of the top function, which is again square root of 2x plus 6, minus the bottom function, which is now x minus 1.
Sir,
Yes?
I'm not sure I get the first part.
This part here?
Yeah.
Okay. Did you understand that the I'm dividing into two regions. One is from -3 until -1, which is this region here. Okay.
Yeah.
And in this little region, the top function is square root of x plus of 2x plus 8 plus 6, and the bottom function is minus the square root of 2x plus 6. This you understand?
Okay, because the straight line begins at -1.
Exactly. At -1, that's where the bottom function becomes a straight line. Exactly. Okay. So this is my first integral. Plus my second integral is from now I'm starting from -1 all the way to 5. Top function is still square root of 2x plus 6 minus bottom function, which is y equals x minus 1.
Sir, do you mind explaining the whole separation thing? I'm kind of lost.
Sure. Okay. So again, we said that to find the area of a region between two functions, we do the top function minus the bottom function over the interval. That you're okay, right?
Yeah.
Okay. The problem is the top function is always the same. Perfect. It's this one. Y equals root of 2x plus 6. Everybody's okay with this, right? You okay with this?
Yeah.
The problem is the bottom function. The bottom function is not the same throughout -3 to 5. It's not the same. Because from -3 to -1, it's the other branch of the parabola. And starting at -1, now it's a line on the bottom. You understand? The bottom function is not the same. It's not the same over the whole interval. So if I want to do top function minus bottom function, well, which function will I choose? This one or this one? The square root here or the line? I don't know. Do you understand?
Yeah. So we're gonna take the small area from -3 to -1.
Exactly.
And then
exactly from
do
minus
the other one.
-1, I'm going to treat. It's like if I separate the area in two sub intervals, but at least from -3 to -1, the bottom function is always the same. And from
So we're saying there's like an imaginary line at -1 that goes up, and we split it into.
I don't know if there's an imaginary line or not, but I'm splitting the interval. I'm cutting this region into two parts and adding the two areas. Yes, that's what I'm doing.
Okay.
I'm sorry, sir. Just to be sure, the reason why we're doing this, is it because at the bottom like branch of the x equals 1/2, is it because that is kind of like the bottom function from -3 to
Exactly.
I guess it's the bottom function throughout the whole thing, but not like, yeah, okay.
Exactly.
Okay, never mind.
Exactly. No, never mind. You said exactly right what you said.
Okay, thank you.
Okay.
Is it okay? Is it okay that a function is like this way? Because if it's like that, it's not like kind of a function, no?
You're right. It's not a function.
Okay.
I didn't say that it was a function here. Just between two curves. Okay. Here
Okay.
I called top function and bottom function because, as you see, I separated into two. That's a function. That's a function. You understand? I separated this curve into two functions, top one and the bottom. Otherwise, you're absolutely right. This is not a function. You're right.
Okay, perfect. Thank you.
How do you know it's at -1 that they cross?
Because I found the intersection point here on the bottom.
Oh.
Right? That's the intersection. They cross at x equals -1 and at x equals 5.
Oh, okay.
Right?
Yeah.
Okay. So let's evaluate this integral now. Okay. I just need some space because you're going to see we're going to do it in a much shorter way in a minute. But let me try to fit it here. So the area is, am I writing too small or you could see?
We could see.
Okay.
No, we could say.
Okay, perfect. So this is the area from -3 to -1. So this is basically square root plus the square root, so 2 times the square root. So 2 times the root of 2x plus 6 dx plus the area from -1 to 5 of square root of 2x plus 6 minus x plus 1 dx. Okay. Okay, this is very easy. It's just it's going to take some space. So what's the antiderivative of this? So we need a substitution. Can I do it mentally? So it's power 3 over 2. So 2x plus 6 power 3 over 2 over 3 over 2. So times 2/3 times 2/3 and then divided by 2. So times 1/3. So I think it's like this. Is this right? Let me double check. If I derive, I get this will cancel. I have, and yeah, perfect. Okay. This is from -3 to -1.
Wait, sir, how did you get to that?
This
Yeah.
substitution u equals 2x plus 6 and so on. Du equals, you'll have 2 u power a half, just like we did, like you did on the last test. Okay, it's just I did a substitution. It's just I would have done it, but I don't have space, or else I erase. But I want to have everything in front. Okay, this do a substitution. I'm going to write here substitution. U here, u equals 2x plus 6. Okay, and du is equal to 2dx. So okay. And here, again, I will have 2x plus 6 to the power of 3 over 2 divided by 3 over 2 divided by 2, so times a third. Okay, and then minus this is x2 over 2, and this is plus x, and all this evaluated from -1 until 5. Are there any questions? Okay, let's evaluate. So if I plug in -1 here, I get 2, or -2 plus 6 is 4, 4 square root is 2, 8, 8, 8, 16/3. Right here. I'm going to put the answer after. 16/3 at -3 is 0. Who cares? 10 at 5. What do I have here? 16, 16, 4, 64, 64/3. Sorry, I'm doing it in my head because this calculation is just arithmetic. Okay. Then 20 minus 25 over 2, and then plus 5. And then if I plug in -1 here, I get 4, 2, 8/3 minus a half minus 1. Okay, so let me calculate the answer. So we get 18, and we're going to do it another way and double check if it's really 18. We could find area in a much more, let's say, efficient way. Okay, by using, so we could do, we could, instead of integrating with respect to x, we will integrate with respect to y. Okay, so the y is, in our case here, it's y is from -2 until 5. Okay, so I will do, in general, from C to D, whatever, C to D, and I will use the right function minus the left function. Okay, and I will integrate this with respect to y. Okay, how does this translate in our problem? Well, the y is from, like I said, -2 until 5. The right function now is the straight line, right? What's on the right? It's a straight line. What's on the left is the parabola. So on the right, I have x is equal to y plus 1. So that's my right function, y plus 1. But of course, I have to express everything in terms of y now. Minus the left function, which is already in y. 1/2 y2 minus 3 dy, and that's it. Much simpler than doing all this. I don't need to separate my region in two. I don't need to, no headaches. I don't need to isolate the y either, okay? So let's try. So the antiderivative,
Sir,
yes?
where is the -2 coming from?
The minus, I'm sorry, minus what?
-2, the bounds.
Oh, because it's the y over here, the y of this point, the lowest point in my region, and the highest point in my region is 5. Okay, so I'm finding all these areas, all the distances between this function and this one, this function and this one, all the way, for all possible values of y, from -2 all the way up until 5.
Sir,
Okay, so
Yes?
isn't it -4, I mean, and not 5?
No, the x is 4. Oh, yeah, you're right. Sorry. Oh, thank you. Yeah, you're right. It's 5. No, so this is, why did I write for 5?
I think we made a mistake in the last
Are you
calculation.
kidding me? We did a mistake here? No, this was 5/4, no?
My y was -2 and 4.
I think you just wrote the point wrong. I think you wrote the x before the you wrote the y before the x.
Let me see.
The x was like 5 and the y 4.
Oh, this is 5 and this is 4?
Yeah, exactly.
Oh, okay, so this is good.
Yeah.
Okay. Oof. Thank you. That would have been a headache if it was wrong. So this is 4, you're right. Okay, perfect. So this here would be 4. So no, not too much harm done. 4, and so this is 4. You're right. Okay.
Sir,
Yes.
what do you mean by right function and left function? Is it just like the way we drew it?
Yeah, the way you drew it. What's on the right, what's on the left.
Okay, perfect.
Okay. So let's simplify this. -1/2 y2 plus y, and then plus 4 dy. Let's find the antiderivative here. So I get -y3 over 6 plus y2 over 2 plus 4x, and all this between evaluated from -2 until 4. Okay, I get 18. Perfect. You got 18 both ways. And as you see, this is much faster.
Sir,
Yes?
please could you explain how we could recognize the right and the left function again?
Sure. So um, if you're at any point in the region, okay, let's say you're in a, I'm just going to erase here a bit. It's too busy inside. If on any point inside my region, okay, I look to the right, where's my function? Oh, this one. I look to the left, where's my function? Oh, this one. At any point. If you're here, look to the right, this is my function. Look to the left, this is my function. That's how you recognize a function. No matter where you are in your region. You understand?
Oh yes, thank you.
Okay. The other way, if you want to know, to recognize what's the top, what's the bottom, right? So if I'm here, what's my top? This, what's my bottom? Here, good. So my bottom is this line. But if I'm here, my top is this curve, the bottom is this curve. Oh, so here, my bottom changed. It's not my line anymore, it's my curve. That's why we have to separate the integral in a sum of two regions. That's for y. You're absolutely right. For example, find the area of the region enclosed by, so the two curves, x equals y squared minus 4y, and x is 2y minus y squared. First thing we do, so we know that I recognize a parabola open to the right. I recognize a parabola open to the left, right? Because the coefficient of y2 is positive, the coefficient of y2 is negative. So let's find the intersection points. Let's put them equal. y2 minus 4y equals 2y minus y2. Send everything to the left. 2y2 minus 6y equals 0. So 2 times y, 2y times y minus 3 equals 0. So either y is 0 or y equals 3. And if y is 0, then x is 0. And if y is 3, so plug in 3 here, let's say. So I get 6 minus 9 is negative. Okay, so my intersections are at 0, 0, and 3, negative 3. Negative 3, sorry. Okay, so 0, 0, and 1, 2, 3, 1, 2, 3. Like this. So this one here is I messed up my graph. It's negative 3 is the other side. That was weird. So negative 3 and 3. Right, that's better. Okay. Just redraw so that I have more space. One, two, three, four. So 0, 0 and negative 3. Okay, this one is open to the right. So something like this. Just want to make sure. This one. And the other one will be that's what it's going to look like. So x is equal to y2 minus 4y. This is x is equal to 2y minus y2. This is the region that I want. Okay. Let's find the integral. So the area, I'm going to do right minus left. So the right function is 2y minus y2 minus the left function, which is y2 minus 4y, and with respect to y. And y goes from 0 until where the limit is 3. There you go. This is my integral. This should give me my area. Let's finish it off. 2y plus, so that's 6y, minus 2y2. And that is 3y2 minus 2y3 over 3, evaluated from 0 to 3. And that is 27 minus, this is 18, 27 minus 18